Hi, everybody from Mission Control Houston. I'm Josh Byerly. I'm joined once again here by Nic Radford, who is the Deputy Project Manager for Robonaut. If you've been watching our coverage this week, you saw quite a bit of activity with Robonaut getting checked out on board by the crew of Expedition 30. Nic, talk about it. It's a big week for you guys. Everything went according to plan, right?
Yeah, it's been a tremendous week. This week was special for a couple of reasons. One, we had our first back-to-back ops. So on Tuesday, Valentine's Day, we got to the control center early in the morning and set up, did our ops, and then temp stowed it overnight, and came back Wednesday morning and completed our second round of ops. So that was good. It was good training for the ground. We envision a lot of that type of operation in the future, where we are, we want to do more and more with this robot, which is going to require back-to-back activities like that. But Wednesday was tremendously successful. Everybody on the ground, and especially the crew in orbit, was having a fantastic time checking out the robot, and we've successfully checked out every joint on the robot and every sensor, and big smiles on our face here in the control center, where we had all the systems are good, and we are ready to go.
Now, talk about what you were seeing the video now. I mean, there was quite a bit of movement and activity with his hands and his fingers and his arms.
Yeah,
right?
Absolutely. We've flown a robot. We've flown a robot for one primary purpose, and that's to do work.
Right.
And in order to do work, we need to have very capable hands and very sensate hands. And so we wanted to make sure that we got all the degrees of freedom working in the hands, getting all the data as we expected it, and making sure that we were going to be able to complete the tasks that we have scheduled for this robot.
Yeah, I think coming up a little bit after this, you'll see the famous handshake in space between...
Yeah, that was an amazing moment. We actually adjusted the timeline slightly because we wanted to make sure we got to this handshake. But yeah, Dan Burbank was absolutely fantastic, and Robonaut reaching its hand out, sensing all the forces that Dan was going to impart into the robot, and then initiating the closure. And I believe Dan said it was a firm handshake.
So let's talk about this. You guys were watching this on the ground. You can actually see the data coming down from Robonaut. So as Dan squeezed his hand,
and
you
we're
can actually
recording
tell
everything. Yeah. So we have predetermined limits that we have accepted in the safety community, that the robot is allowed to impart in its environment. Let's not forget, this is one of the first payloads ever on the space station that can actually impart forces in its environment. So there really wasn't a specification for how to fly a payload such as this. So we used a lot of the framework from how the crew would interact with the space station, and so we've made sure that the robot doesn't impart anything above its limits. And so we record all that data on the ground and make sure that it's that our sensors are always reading the values that they should, because it is a very serious thing. We want to make sure that it's always remains safe.
Well, I mean, there's been people on the Twitter accounts and things like that. They smile about this because they compare it to either one of the Cylons from Battlestar Galactica or the Terminator or whatever.
Our next checkout is to try to take over the space station. Okay. So we're not trying to promote that too much, but
fly it away. Well, I mean, talk about some of this, because we saw one of the crew members just sort of bumped into it a little bit before, and it shut down.
Yeah, absolutely. We have a hair trigger safety system right now that is by design. We have one of the agreements we made with the safety community was it was going to be almost difficult to operate at first, because we wanted every small little contact to safe the robot, and we wanted to assess what happened. And what you're referring to, I think, is one of the crew members was floating by right before we were getting ready to do the handshake, and just brushed up against the robot, and the robot wasn't expecting it. It hit it in an area we weren't ready for that upcoming task, and the robot said, let's shut down, let's restart. And so we were actually very excited to see that, because it operated exactly the way that it was supposed to, and we recovered really quickly from that, and so it's operating very nominally.
Well, and it boots back up pretty fast. I mean, I don't think my laptop starts back up as fast as what you guys had it turned back on and ready to go with a handshake. I mean, it was just a matter of minutes.
And that's been a very interesting learning experience for us as well, because the data connections, the network connections, they're not like being down here, operating the robot in the lab. And so having to deal with comm dropouts and refresh rates that are really slow, it's been a great learning experience that we're going to. It'll definitely pay dividends in the future for more complicated operations.
So let's talk once again about this task bar. Now, we talked about this earlier this week, that there's this sort of kind of an experiment kit that the robot's going to be trying to flip some switches and do some other things. When is that going to happen, and what's next?
Yeah, so we've essentially essentially divided the operations of the robot into two stages. One, we have all these free space motions.
Right.
And then the second stage of the operation is all contact operations. So we wanted to make sure that the robot behaves, and that so the commissioning of the robot is going to transition from more or less waving its arms around, if you will,
Yeah.
and assessing and retuning the robot as required for the differences between here on the ground and in orbit. And then we are going to move on to, all right, let's start touching things.
Okay.
Let's start interacting with objects. Let's start making contact, deliberately making contact with objects. Now you can say the handshake yesterday was it's kind of a contact operation, but that things are very compliant still. You're not
Yeah.
making contact with rigid objects, and where
To
you
flip
have
a switch.
to
And
flip a
yeah.
switch, where you have the potential to build up really large forces.
Yeah.
And so, on the docket for us is absolutely to use the busy board that we have. We are training the robot on the ground, and you're seeing some video right now of that. And it's not just necessarily, hey, let's have the robot perform these, but let's have it perform it intelligently. Did it flip the switch? Did it recognize it flipped the switch when it needed to? Is it going to correct back when it didn't flip the switch? The button presses, did it understand that it did a successful operation? And so it's combining the intelligence that it takes to actually interact with the objects and the crew, and that's what we are learning here on the ground, and we want to upload those capabilities to the one in orbit, and that's why we have an identical copy here on the ground that is a complete replica of both the busy board and the robot, because we want to be able to simulate everything on the ground, simulate it in hardware, and then upload those routines to the one in orbit.
So are they going to do this in the Destiny laboratory where it's stored right now?
Yeah, absolutely. This first panel here that you're looking at is on our list of things coming up that we want to do. It involves an integration between our vision system, the tactile feedback, and the sensors of the hand, and the control systems that are controlling this robot all have to be acting and harmoniously and successfully. So it's a very there's a lot of serial things that all have to be working before the robot does a function.
Well, this is all very cool stuff. So
Yeah.
it's been a cool week sitting here watching this activity take place.
Yeah, it's been an amazing week for the engineering team and the flight control team and the crew, and we actually got a call from Dan right after the op. He called down to our lab and just wanted to say a few words to us personally, and he's tremendously excited to be working with this, and I can't say enough about Dan. He is unbelievable when operating this robot. He just gets it, and he's been an absolute pleasure to work with.
It's got to be fun doing something that's literally brand new like this.
Yeah,
Actually,
yeah. It has been very just. It's hard to describe. It really is, because our whole lab has this sense of of ushering in this new paradigm, and we're really excited to be at the front of that.